Hi. Well, today we are going to look at the last section of this section 5.9, and this deals with functions. So we're going to be going back to functions. Again, for some of you, this may be a little difficult because you're not used to seeing it in this form, but I'm hoping that you'll get more and more comfortable with it as we use these. Now, we're going to be adding functions just like we added polynomials. We'll be subtracting functions just like we subtracted polynomials earlier in this chapter, also multiplying and dividing. So you're going to see some similarities. It's just the initial look is a little different. So we'll try to get you through that initial look so that you know what to do, depending upon how they present it and how they may how they may present the problem. All righty, so let's look here. We now know what a function is. Okay, in this section, we will learn the ways that functions can be combined together. So let's go back. We now know what a function is. Well, let's kind of review. A function, again, passes the vertical line test. And we also know that when we have a function, we have every x has just one y value that it's equal to. So in functions, you'll never have like a y squared. It'll just be, you can have an x squared, but never a y squared. So for our purposes, these right here in our functions represent the y. All right, so let's continue on. We can do our standard for operations on functions just like we do with numbers. That is, functions can be added, subtracted, multiplied, or divided to get new functions, numbers or our polynomials. All righty. So let's go ahead and go through some examples and hopefully that'll help. So we've got f of x plus g of x. That's what they want. What does this mean? They want you to take the f function, this is red, f of x as a review, plus g of x. So here we'll take what f of x is equal to. F of x is equal to x plus 4. And we're going to add to it the g of x function. Well, g of x is equal to x squared plus 1. So now all you do is you combine like terms, which we've done before. All righty, so when they give you a problem like this, they want you to take whatever the f of x is equal to and add the g of x, whatever it's equal to. And then you do have to simplify it or Pearson will not count it right. So I'm going to put our highest power first. And then we have x. And then 4 plus 1 is 5. So this is equal to that. You're adding those two functions together. All right. Let's look at another one. How do we subtract them? Now you have to be really kind of careful about the subtraction because when you subtract, just like when we had the polynomials, we had parentheses around them and we had to change the sign on the following polynomial. Well, this is going to be the same thing. What I'm going to do with subtraction that I did not do with addition is I'm going to use parentheses around both of these. So I'm going to have x plus 4, parentheses, that's what this is, subtract, g of x is x squared plus 1. Now, the reason I did that, and this is where the mistakes are made, is that when you have a subtraction, the following parentheses, the signs change. Not in the previous parentheses, but in the following parentheses. So this is actually x plus 4. It's a positive x squared on the inside, so now it's a minus x squared minus 1. So you can think of it as this will change all of the signs. It's like multiplying by a -1, change all the signs on the inside. And now you're back to where we were earlier. You combine like terms. So we've got a minus x squared. I'll start with the highest power. We have a plus x that has to stay by itself. and now it's a plus 3, 4 and a negative 1. Okay, so if you subtract those two functions, that's what you get. You just have to be careful of this minus, and it'll change the sign on the following function is all. All right, now let's multiply our two functions together. We'll take f of x times g of x. Well, f of x times g of x. Okay, so you have a couple of methods. You can use the FOIL method, the first times the first, outside, inside. And this one is a little bit different than what you might be used to using the FOIL method. And we'll look at that here in a second. And then the last times the last. Or you can take x times both of those plus 4 times both of those and combine your like terms. I want to use the FOIL method here real quick, because we will be using the FOIL method in the next chapter. So we take the first term times the first term in each parentheses. That's what the F stands for. The first term times the first term. Adding exponents, we get x cubed for our first term. Then we do the outside. That's the O. That gives us x. And then we do the I, which is the inside. That gives us 4x squared. Normally, we add those together. 99% of the time, it seems that you'll be able to add those two together. But in this case, you can't. They're not like terms. So that when you come over here to write your answer, you have to keep them separate. So there's the O is here, and there's your I. And then the last times the last, 4 times 1, which is 4. Okay, so if you would have used that distributive property twice, you'll get the same answer when you combine your like terms. That's what you should get. That is the f function times the g function. Let's do our last one here, division. And I'm going to cover up some of this. All right, so this we're going to take f of x divided by g of x. Now, f of x is x plus 4. G of x is x squared plus 1. Now, we're not reducing these. You can't reduce this one. And when we later in one of the chapters, we'll be reducing fractions, but in this case, it can't be reduced. So chances are you won't be doing reducing much in this section. So those are our answers. We added, subtracted, multiplied, and divided functions. All righty. Now let's look at some different notation that they might use on you and explain that notation to you. The first notation here, and we'll be talking about the domain, I think on the next page. But let's just talk about the notation. This would be read f plus g of x. All right. This is equal to what we did above on the first example on A, f of x plus g of x. So if it's written like this, you can rewrite it like this if it helps to solve it. These two represent the same thing. Here, once again, you can look at it this way, and some people do, or you can make them separate, f of x subtract g of x, just like what we did on B up above. Also, multiplication can be written like this, and you may see it like this. You can rewrite it as f of x times g of x, all right, and get the same answer. So you can rewrite, if it's given in this form, you can rewrite it like this and take f of x times g of x. Again, with division, we can separate them, but notice we have this stipulation here. G of x cannot equal 0. Why did they say that? Well, because in in our mathematics, we cannot have a 0 down here. So they're clarifying that g of x will never be 0 because we cannot have a 0 in the denominator. That's all that means. You cannot have a 0 in the denominator. As far as solving it, it really has no part in it. Just to know, they're just stating that g of x cannot equal 0. So we're going to go through some examples using this nomenclature or this one right here, and just kind of work with both of those and put some numbers in. I don't think they gave us enough room, so I'm going to use a scratch piece of paper. All right, f plus g of 3. All right, so what I'm going to do is I'm going to go ahead and write it like this, because to me this seems a little bit easier. So I'm going to take this and write f of 3 plus g of 3. Now, how do I solve this? Normally, like the ones above, we had an x, but now it's a 3. This means you put 3 in for the x. Whatever you have here goes in for the x's, these variables. So f of 3 is 3 squared minus 3. Okay, that's f of 3. I just put in 3 for the x's. And 9 minus 3, I get 6. Oh, let me move that up a bit here. I ran off the page. Okay. So let's do our g of 3. So you put 3 in for that x. So all you do is you replace 3 in right there. And you get 5. Now, what did they want you to do with g of f of 3 and g of 3? Well, they wanted us to add. Sometimes they may want you to subtract. Sometimes they may want you to multiply or divide the answers that you got. In this case, they want us to add the 6 plus the 5, and you get 11. So you're substituting this number inside the parentheses that's next to this variable here, this function name. You're putting this number in for all the x's and seeing what you get. You put 3 into all the x's in the g function, and then they want you to add them together. So to me, it makes a lot more sense to take this and rewrite it separately with a plus sign. It's a little bit easier. All righty. Okay, let's, and then some of you get to a point where you will just do that. You'll just put, oh, I'll put 3 into the F, I'll put 3 into the G, and I'll add them. You don't need to rewrite it. You know, it's up to you. Let's look at B. Okay. On B here, first off, they have 2 parts. First, they want us to do this, and then they want us to look at this. And we're going to look at this first, and then we'll talk about the different ways you can do this one. We'll go f of x minus g of x. So I rewrote this one like this, using this number 2. Okay, I rewrote it. Now I'm going to put, just like we put the 3 in for the x, now I'm going to put an x in for x, which seems kind of crazy, but that's exactly what's happening. If you put x into here, or just think of it as f of x, which is x squared minus x. And the reason I say that is if they had an a here instead of an x, you'd have a squared minus a. So you're replacing the x's with whatever's here. In this case, you're kind of replacing an x with an x, and it doesn't change it. Now, because I'm using subtraction, I'm going to use these parentheses, just so that I don't forget to change the sign on the g. So I've got g of x, which is x plus 2. So now I simplify. X squared minus x minus 2. Because this changed, it's a minus x now and a minus 2. Combining our like terms. Okay. What I have found right here is the function equation for this right here. All right, so this is now equal to this. Oops, I guess you can't see me pointing. Let me say that again. This here, this right here, this whole subtraction is equal to this. So I'm going to rewrite it below. This is x squared minus 2x minus 2. Now you can use this function, all righty? You can use this function right here to find this. You can just put a -1 into here. Now that you've found the function, you can use it. If that had been a 3, you would have put 3 in, or a 4, you would put 4 in. So you can use this new function that you found, this subtraction function, and just replace the -1 in here, which I will do. Oh, I was going to do it right. Yeah, I can do it right below. So that gives us -1 squared. So using your calculator, you got to have parentheses, minus 2 times the -1 minus 2. So I can put the -1 into my new function I found by subtracting those two individually. 1 plus 2 minus 2. 3 minus 2 is 1. So the answer is 1. But if I didn't have this function, if I hadn't found that function, then I would have done this problem like I did this one. So let's go through that, and you'll see that whether or not you use your new function and put in a -1, or treat it like we did this one by writing f of a -1 minus g of a -1, separating it out using this idea. You put in -1 into the f function. So that gives me -1 squared minus a -1. So both of the x's were replaced with -1s. I guess I'll use a bracket since I have so many parentheses. Minus the g of a -1 is just a -1 plus 2. So I put the -1 into the g function as well. I'm going to get these separate and then subtract them. We should get the same answer as if we use this one, the new function we found. Well, a -1 squared is a +1. Minus and a minus, two negatives is a +1. So our f of a -1 is equal to 2. If you put a -1 into the g function, you're going to get 1. So we have 2 minus, that is 1, which is 1. So you can see that if you use your new function you found and put in a -1, or you separate them, just like we did this first one, you can separate them and put -1 into the f, -1 into the g, and then subtract those answers, you'll get the same answer. Just, it's up to you. Sometimes if you know you have this right because Pearson's checked it, it might be easier just to put the -1 into your new function that you found by subtracting those. All righty, let's look at a division one. So we're going to take f of x. We're on number C, coincides to 4. We're going to take f of x and divide that by g of x. All right, these two can be written like this here. And that is going to be equal to x squared minus x over the g of x, which is x plus 2. So there's my function. So that would answer the question here. This would be the answer there. Now to do f of 4, since I did find this, and rather than putting 4 into the f function, which is kind of what we're doing, divided by g of 4, we'll just use this. So we're going to put in 4 to find f over g of 4. 4 plus 2. 16 minus 4 over 6. Yeah, make sure that you can see that. This gives us 12 over 6 or 2. All righty. So this is the answer. This right here is the answer to here. And then we use that function, that new one we just found, and put a 4 in for the x's. And we come up with the number 2. All righty. That's awesome. Here's our multiplication. I'm wondering if they're going to do multiplication. Okay, multiplication, they don't want you to find the f dot g of x. Okay, they don't want you to find that, like we did in B and C there. So what we'll do is to find this, because we don't have the multiplication function. We didn't figure that out. We'll just do f of 3 times g of 3 without finding this one first, like we did here and here. So we'll just use this method since I don't have that multiplication. What do we get? Well, if you put 3 into the f function, which is clear up here, we'd have 3 squared minus 3. Times, you put 3 into the g function, 3 plus 2. And then you multiply those two answers together. This gives us 9 minus 3 is 6. 3 plus 2 is 5. So the answer is 30. So you've got some options here as far as finding this and using it, or doing something like this, where you find them separate and then you do the operation they want you to do. Okay, well, I'm hopefully that made sense, because now we're going to talk about domains and graphs. The graphs is on the next page. All right, we hit domains a lot. So we've talked about them before, we're going to talk about them again. All right, so just like we can find the domain of each individual function, we need to be able to determine the domain of the sum, difference, product, or quotient of functions. Once you find the domain of each individual function, to find the domain of any combination, we just take all the x values in common. All right, and that'll make sense when we do an example. All right, so to find the domain of a sum, difference, product, or quotient, first off, you're going to find the domain of f, and you're going to find the domain of g. Then the domain of f plus g, f minus g, and f times g are the x values that are common in both the domains of f and g. All right, so exactly. Noel here, the domain of f over g is special. This division is special because this adds an extra dimension to the domain, because this cannot be 0. So you're going to have to add 1 to this one. These are all going to be the same. Okay, these are all going to be the same. This one's going to also have what these guys have, plus an extra from this denominator here. So let's go ahead and go through some examples. Let's start with this first one. Okay, we have given f of x equals 1 over x and g of x equals 2x minus 7. Find the domains of f plus g, f minus g, f times g, and f divided by g. So what you're going to have to do is find the domain of these individually. The domain of this one, we know that when we have a fraction, and that's the only, we haven't done square roots yet. We're going to do those later, how to find the domain of a square root. All we know is that when we have a fraction, the denominator cannot be 0. All right. So I know that the domain of f of x is x cannot be 0, because if you put in 0, you get a 0 down here. All right. Now, what's the domain of g of x? Well, there is no fraction here. And so this is just a line that goes in both directions. There's nothing you cannot put in here. So this one is a negative infinity to infinity, or all real numbers. All righty. So when we go to look at these individually, what do we use? We use this one right here for all of those. So because f appears in all of these, you cannot have x cannot be 0. All right, because f appears in all of those. This one's not limited. So this one does not limit any of these domains, but this one does. So looking at this, f plus g, the domain, no, I'll just put it here. I'm going to put it up above, so I have to keep writing it. The domain of f plus g is x cannot equal 0. The domain of f minus g is x cannot equal 0. The domain of f times g is x cannot equal 0. The domain of f over g is x cannot equal 0 plus another one. All right, so all of these have this restricted domain here, but this one, I know that it has an additional, in that the denominator, g of x, g, they just have g, cannot be 0, so 2x minus 7 cannot be 0. So you take whatever the denominator is, and you know that that denominator cannot be 0, and you solve it. Yeah, I got plenty of room. Divide by 2, x cannot be 7/2. So this is x cannot equal 0, and they may have you use a comma, x cannot equal 7/2. All right, so finishing up this, I'm not sure if you could see that when I was doing that. I just moved it up. So here we have an additional for this one. They're all the same, plus this additional. The denominator cannot be 0, and you just solve it, and there's your additional one. Okay, that's how you find the domain of all of these, is by looking at these individuals. All right, let's see what they have for us for another one. Okay, this one won't be too bad. We want the domain of these 3. So what does that mean? We'll go ahead, and we know that looking at the domain of this one, 2 minus x cannot be 0. The denominator cannot be 0. We're just looking at f of x. So solving this, a negative x, subtract 2, divide by a negative 1, divide by negative 1, x cannot equal 2. So there's a domain. X cannot be 2. Let's go to the g of x here. What's the domain of g of x? That its denominator cannot be 0. X cannot be 4. So let's start listing over here each of the denominators. For f plus g, the denominator is x cannot be 2, x cannot be 4. F minus g, x cannot be 2, x cannot be 4. F times g, you cannot use a 2 in this function or a 4. F over g, x cannot equal 2, x cannot equal 4, and there may be another one. Sorry, again, forgot to move that up. There may be an additional one. Let's see, let's take this and set it equal to 0. It's not going to add an additional one. But we'll go ahead and go through this. This is 1 over 2 minus x divided by 13 over x minus 4. So here, you still can't have x cannot equal 4 in this function. This takes a little bit more algebra than what we're ready for yet, because we will work with these complex fractions in chapter 7. So here again, it doesn't change it. You still can't have a 4. If there had been an x with a 13, then we would have had something to add. If there had been an x there, then we know that x could not be 0. You can't have that down here. You can't have a 0 down here. But otherwise, in this case, it just happens to stay the same. All right, that can't be 0 and that can't be 0. All right. So there we go. That's how you find the domains, is looking at the individuals, and then on this one, looking at the G function for your additional one, if you're going to have an additional one. Sometimes you don't, like we did on the last one. All righty. Now we're going to look at graphs. So looking at this right here, sorry, I'm going to straighten that out. All right, in 2004, a study comparing high doses of cholesterol-lowering drugs, Lipitor and Provokal, indicated that patients taking Lipitor were significantly less likely to have heart attacks. All right, so here we've got follow-up and the percent of having a heart attack along here. Let's see. In the following graph, L sub t is the percentage of patients on Lipitor, and P sub t is the percentage of patients on Provokal. Who suffered heart problems or death T years after beginning to take the medication? So this is, 15% of the people either had heart complications or death. So knowing that, let's see what we've got here. Use estimates of P sub 2 and L sub 2 to estimate P minus L of 2. So you have to remember, this right here is the same thing as P sub 2 minus L sub 2. Okay, so let's look at that, and we'll talk about what does this represent. Well, we go to P of 2, so that means 2 years on a follow-up. Let's see, I'm hoping it's roughly 27, maybe. It's right up here. You go to 2 on the x-axis and you go up to the y, and it's roughly 27 minus L of 2. You go to 2 because that's the x. That's what we replace the x with. And you go up and it looks like, oh, wow, between those 22.5. It's like right here, which is halfway between 20 and 25, which is 22.5. Okay. I don't think that one was going to be a half. These are just estimates. Okay, now we subtract the Provokal after 2 years and the Lipitor after your 2 years, and you're going to get 4.5%. Okay, what does this mean? Well, 4.5% of people on Provokal had a higher risk than Lipitor after 2 years. Okay, there was a 4.5%. You could think of it as an increase from, those taking Lipitor to Provokal, or the fact that these guys had a higher rate of 4.5% after 2 years. Just all depends on how they want to word that. Okay, so here is 4.5%. Now, let's look at another one. Use estimates at 1. So at 1 year, so we're going to take piece of 1 minus L of 1. That's what that means. So we go to, let's see, P is 20% minus Lipitor after 1 year. Looks like we've got our 17.5. Okay. So a 2.5% increase in death rate between Provocol and the Lipitor. The Provocol is seeming to be more risky. So, all righty. Well, that's how you can use a graph to find these. These are the X's. You go to the X, you go up to the graph, and this will be equal to the Y value. All right, let's look at another one. Example that deals with finding the domain giving a graph. So what we have is we've got the F, okay, determine F plus G of 5. So we're going to separate it like we did in the previous problems with the algebra though. And we're going to find the 5. What's F of 5? F is the red. So we go to 5 on the X, and the F function is equal to 1. So that's the Y coordinate. So there's your X, there's the Y coordinate on the F function, which is red. Then we're going to do the same thing with the G function. We're going to go to 5 on the, okay, so there's 5. We're going to go to the G function, which is blue. And that Y coordinate is 3. And then we add them together for our answer. So again, this is the X, and you go to 5 on the X-axis, and then you go up to the F and see what the Y coordinate is equal to. It's 1. And you go to 5, you go up to the G, and that Y coordinate is 3. And then you add them together. Now here we want to multiply. So we'll take F of 5 times G of 5. We've already found those. That's a 1. And G of 5, the Y coordinate is a 3. And we come up with 3. So now we're going to look at the domains of F and G. Well, let's look at the domain of F. The domain of F goes from 1 to 9. Okay, excuse me, not 1 to 9, I'm sorry, 0 to 9. So your domain starts here. It's got a point, doesn't have an arrow. So it goes from 0 to 9. Domains are the X's. So this one, we can use interval notation here, 0 to 9. The G function goes from 3 to 10. So it starts at 3 and it stops at 10. Okay. Knowing that, what is the domains of these right here? Okay. Well, you want these combined, all right? Like all of them have an F, so none of these that you have to use only 0 to 9. And these, the G of X, you can only use 3 to 10. So this is an and you want what's in common. So because you're using them both, you can only go from here to here. You can only use this section where both of those are defined when you do these. All right, this is an and. Okay, what's in common here on these graphs? So you can only go from 3 to 9. And so each of these goes from 3 to 9. Then this one, that's for this one. Here, 3 to 9. Here, 3 to 9. You see those? Yes. And then f divided by g. Oh, this is interesting. F divided by g, 3 and 9, but g cannot be 0. We have to add something to this, or maybe, exclude something in this interval. When is the g function equal to 0? Well, that means it has a y value of 0. The g never has a y value of 0. So so we don't have this right here. We don't have to add an additional for f over g because the g function never touches it. It doesn't have a y value of 0. It's never equal to 0. But what about this guy? Well, we know we can go 3 to 9, right? But f cannot be 0. Is there a time when f is equal to 0? There's 2 times, 6 and 8. So we have x cannot equal to 6 and x cannot equal 8. Now, how might Pearson want, because the 6 and the 8 are in this interval. So you could do 3 to 6 unioned with, not a bracket. It's got to be a parentheses. It's got to be a parentheses. We cannot include the 6. Unioned with 6 to 8. Unioned with 8 to 9. I'm hoping they will let you write it like this. I just didn't look. I forgot to look. All righty. So again, you have the same, except on these divisions, you might have an additional. And that's when the denominator is 0, which is at 6, has a value of 0, and 8 has a value of 0. So you can use everything in here except those 2. All righty. Okay, we are done, I believe, with 5.9. And again, if functions are giving you some issues, I highly recommend that you let me know and we can go through maybe some of your homework problems. Be happy to. Just either shoot me an email or text. All right. Thank you and have a good day.